For, well, over a century now, some of the greatest minds in physics have really been striving for this unified theory, right? A kind of grand framework.
Exactly. Something that harmonizes the quantum world, the really tiny stuff, with the cosmos, the galaxies, everything.
Reconciling that subatomic dance with, well, the majesty of the universe.
Yeah.
And the question hangs there. Could it be that the time for such a revelation is maybe finally here?
It's a tantalizing thought.
Absolutely. And that brings you to the analysis of the DDTF quantum theory. Today, we're diving deep into a theory that proposes exactly that kind of unification, the decoherence-determined time flow theory, or DDTF for short.
And it's important to say this isn't just another scientific hypothesis floating around. It's a quantum theory, yes, but it really boldly reaches into philosophy, even theology.
Offering a really fresh, pretty expansive perspective on existence itself.
Yeah.
So our mission today is to unpack the core ideas of DDTF. We'll explore its implications, which are radical, frankly, for time, space-time, gravity, even consciousness.
And we'll try to connect these sometimes pretty complex ideas back to the grand narrative of our universe. So yeah, get ready to maybe rethink a few things you thought you knew about reality.
Okay, let's start right at the beginning then. What is the absolute fundamental idea behind this decoherence-determined time flow theory? How does it even propose that time itself comes into being?
Right. Well, the DDTF theory basically flips our usual understanding of time on its head. The core principle is that time and space-time and even gravity, they aren't fundamental pre-existing things. They're not just there.
Okay, not the background stage then.
Exactly. Instead, DDTF argues they emerge. They come directly out of a quantum process called decoherence.
Decoherence. Okay, unpack that a bit.
So to understand this emergence, the theory introduces something called decoherence density, which it labels Q. Think of Q, well, a measure of how often and how fast quantum decoherences are happening in a particular area.
And decoherence itself is?
It's when a quantum system, which can exist in multiple states at once, superposition interacts with its environment. That interaction forces it to kind of settle into just one definite state.
Like the classic spinning coin analogy. While it's spinning, it's both. But when it lands, interacts with the table, it's definitely heads or tails.
Precisely. That landing is like decoherence. Now, here's the kicker. DDTF says the flow of time, let's call it F, is inversely proportional to this decoherence density, Q.
Inversely proportional. So F is like 1 over Q.
Exactly. F is proportional to 1Q. And the implication is huge. It means the more quantum decoherences are happening in an area, the higher Q is, the more condensed time becomes there. It effectively slows down.
Whoa. Okay. So time isn't a constant river.
Not according to DDTF. It's a river that's created and shaped by these quantum interactions. When all these tiny quantum particles interact and settle, they build up this density of interactions, Q.
So more interactions, more settling, means slower time in that spot.
That's the idea. The theory suggests the more quantum decisions or interactions happen in one place, the slower time feels or flows there. Think about being in a really crowded, busy place. Sometimes it feels like things are happening in slow motion, right?
Yeah, or like you're wading through something thicker.
Exactly. That feeling of things being condensed or slowed down is kind of analogous to how DDTF pictures time behaving when Q is high.
That really is a revolutionary way to think about time. Okay, so if time itself emerges from this decoherence process, how does the theory handle the very beginning, the Big Bang?
Right, the Big Bang gets a major reinterpretation in DDTF. It's not just seen as a massive explosion in space and time, it's seen as the universe's initial colossal act of decoherence.
The first big settling.
Biggest one. Before what we think of as measurable time, the universe, or maybe its potential, existed in a state DDTF calls the quantum undisturbed substrate, the QUS.
Quantum undisturbed substrate.
Right.
What's that like?
It's described as a state of pure quantum possibilities. A realm without time as we know it at all. Just infinite potential, everything that could be, existing together in a timeless, coherent state. No past, no future, just potential.
Wow.
Then comes the event we call the Big Bang. But in DDTF, it wasn't just an outward burst of energy, it was the primary universe-scale act of decoherence. The moment when all those infinite possibilities held in the QUS started to resolve, to collapse into definite, actual realities.
So the universe decided to become real, in a way.
You could put it like that. This huge decision to manifest was the trigger. It marked the onset of time itself. This first wave of decoherence didn't just start time, it also gave birth to space and gravity, all driven by this rapidly increasing decoherence density Q that was unleashed.
So the Big Bang is reframed.
Exactly. DDTF calls it the cosmic space-time unfolding, or genesis. It emphasizes this act of creation from quantum possibility, rather than just expansion within something already there. It was the true genesis of space-time as we know it.
Okay, so time emerges, driven by Q, and gravity emerges too. How does DDTF fit gravity into this picture? It's usually seen as bending space-time.
Yeah, and this is one of the really neat integrations in DDTF. It suggests gravity isn't a fundamental force in the way we usually think of it, not something that intrinsically pulls things or bends space-time by itself.
So what is it then?
It's seen as a direct manifestation of the local decoherence density, Q. So places with strong gravity, like near a planet or a star, they're simply regions where Q is extremely high.
Because there's lots of matter and energy, lots of interaction.
Precisely. Lots of quantum systems interacting and decohering. Now remember that inverse relationship, time flow F is proportional to 1Q. So where Q is very high because of strong gravity,
Time flow F must be very low. Time slows down.
exactly. The high Q locally reduces the flow of time. And DDTF says that's what gravity is. What we feel as a pull, the reason things fall, it's a consequence of this local slowing of time.
So things fall towards massive objects because they're moving towards where time flows slower.
That's the concept. It's not a force pulling them, it's them naturally following the gradient towards slower time. Think about rolling a marble on a stretched rubber sheet with a heavy ball in the middle making a dip.
Right, the marble rolls into the dip.
Yeah, not because the dip pulls it, but because the surface itself is curved, or you could say slowed down in that area. DDTF offers this quantum-based explanation for gravity, linking it directly to how time itself emerges.
Okay, so gravity and time are fundamentally linked through this Q factor. Does that mean space-time itself is also dynamic, not just a fixed backdrop?
Oh, absolutely. It's not just dynamic. The theory suggests it's constantly being woven. DDTF doesn't see space-time as a static background at all. It's described as a dynamic Q field.
A Q field.
Yeah, meaning the curvature of space-time that Einstein describes so well in general relativity. That curvature is directly created by the local ups and downs in the decoherence density, Q. Wherever Q is higher, the Q field of space-time gets more condensed, creating the curvature.
And this is happening all the time, everywhere.
It's a continuous, ongoing process. The very fabric of space-time is constantly being knitted together, woven and rewoven by all the quantum decoherence happening throughout the universe. Every single tiny quantum interaction, every time a quantum system collapses from superposition into a definite state.
It's like the idea of the stitch to the fabric.
Exactly. That's a great analogy. Imagine space-time as this huge, flexible tapestry that's always being worked on, where there are lots of stitches close together. That's high Q. The fabric is denser, more bunched up, more curved. The universe isn't just existing on this fabric. The universe is the fabric, constantly being constructed by these quantum events. It's a living structure.
This idea of Q shaping things. It sounds like it might connect to another quantum puzzle, wave-particle duality. You know, why sometimes things act like waves and sometimes like particles. How does DDTF relate that to the de Broglie wavelength?
That's a really sharp connection to make. And yes, DDTF does offer insight here. Wave-particle duality is fundamental, right? Everything has wave properties described by its de Broglie wavelength. Bigger momentum means smaller wavelength, so big things look like solid particles.
And tiny things like electrons can act very wave-like.
Exactly. DDTF brings decoherence density, Q, right into the heart of this. It suggests Q plays a decisive role in whether something appears predominantly wave-like or particle-like.
How so?
Well, think about large objects or particles with high momentum. They're constantly interacting with their environment, bumping into air molecules, photons, whatever. This leads to a very high Q in their immediate vicinity.
Lots of decoherence happening around them.
Right. And this high Q, according to the theory, effectively suppresses their wave properties. It forces them into classical particle-like behavior. Their de Broglie wavelength becomes vanishingly small, they lose their quantum phase difference with the environment very quickly, and they become definite objects.
Like the heavy balloon analogy, you use too many interactions, it just looks like a balloon.
Exactly. More disturbances, less wave-like. Now flip that. Think about small particles, like an electron isolated in a vacuum, or particles with very low momentum. They interact much less frequently.
So low Q around them.
Very low Q. And this allows their inherent wave properties to be preserved for much longer. Their quantum blurriness remains intact, manifesting as a larger, more noticeable de Broglie wavelength. They maintain their phase relationship with the quantum world, staying in a more quantum state.
Like the light balloon, in a vacuum fewer disturbances, it seems more like a wave, a cloud of possibilities.
Precisely. So in DDTF, Q isn't just about the flow of time, it's also the mechanism that seems to de-quantize the world around us. It transforms that inherent quantum fuzziness into the definite classical objects we perceive. It dictates how collapsed or manifest something appears.
Okay, given this whole framework, what about the Schrödinger equation? It's the bedrock equation describing how quantum systems evolve over time. How does that fit in?
Right. The Schrödinger equation is absolutely central. It describes how the wave function of a quantum system changes deterministically over time, T. Now, within DDTF, that T in the equation is specifically the conventional measurable time, the time that, as we've been saying, emerges from decoherence.
So the equation still works within this emergent time.
Yes, it describes the evolution within the time created by Q. But DDTF adds another layer, a deeper perspective, by connecting it back to the quantum undisturbed substrate, the QUS.
That timeless realm of potential.
Exactly. The QUS is seen as the eternal source from which information continuously flows to generate our manifest spacetime. So the Schrödinger equation can be understood as the instruction set, or the code, that dictates how this information from the QUS is structured and how it evolves before it fully manifests as specific spacetime events through decoherence.
Like the underlying rules for how potential becomes actual.
Kind of like that, yeah. It governs the potential's evolution. It's also interesting, mathematically, the Schrödinger equation looks a bit like a heat equation. And in DDTF, heat is linked to Q, because more heat means more interactions, more decoherence, more energy dissipation. So the equation's form itself might hint at this connection.
So it's like the blueprint's instructions for change over time.
Right, but DDTF adds that the building materials for reality come from this vast, timeless quarry, the QUS, where all possible forms exist. The equation isn't just describing change in our emergent time, it's describing how potentials from that timeless source become real, with the time we experience being a result of this whole construction process. It gives a sort of dual perspective on time.
Fascinating. And what about probability in quantum mechanics? The Born rule tells us how to calculate the odds of finding a particle in a certain state. Does DDTF offer an origin story for probability itself?
The Born rule. Yes, it's fundamental. It says the probability of getting a specific outcome is the square of the amplitude of the wave function for that outcome. But it's usually just stated as a rule, a postulate. It works incredibly well, but why is it the amplitude squared?
Right, where does that rule come from?
DDTF offers a conceptual origin. It views the quantum world, the wave function, as this incredibly complex network of information. When a measurement happens, DDTF proposes it's not just a passive observation, but a dynamic process. It talks about projecting quantum information from the QUS into our manifest spacetime.
Projecting information, how does that work?
The theory suggests that during a measurement, the change in decoherence density, Q, activates a scalar field. Let's call it phi. This phi field acts like a projector or maybe a filter. It selects information from the QUS based on its strength or intensity, which is encoded in the wave function amplitudes.
Okay, and the Born rule connection.
The key idea is that the intensity with which this phi field projects each possible outcome is directly proportional to the square of that outcome's wave function amplitude. So the outcomes with larger amplitudes get projected more strongly, more probably.
So it provides a physical mechanism for why probability scales with the amplitude squared.
Exactly. It attempts to ground the Born rule in the dynamics of time, emergence, and information flow, rather than just accepting it as a given rule. It's like those quantum possibilities are different colored lights, their brightness being the amplitude. The Born rule says you see one color, chance based on brightness squared. DDTF adds the projector the phi field activated by observation, change in Q, which naturally favors showing the brighter lights, and the chance of seeing one is its brightness squared. It suggests observation isn't random chance, but a physical projection process.
That's quite a different take. Let's talk about entanglement then. That spooky action at a distance. How does DDTF handle that mystery?
Entanglement is definitely one of the spookiest. Two particles linked, measure one, the other instantly knows no matter how far apart. Seems to violate locality, the speed of light limit.
Right, so how does DDTF explain this instantaneous connection?
It offers a really interesting perspective based on that QUS idea. It suggests entangled particles share what it calls a common chronodynamic integrity. This shared integrity is a direct link back to the QUS.
Chronodynamic integrity, meaning related to time dynamics.
Yes, it means their fundamental connection is so deep, originating from the timeless QUS, that it effectively shields them from local variations in decoherence density, Q, and even from the space-time curvature caused by gravity.
They're immune to local time effects.
In a crucial way, yes. Because their shared integrity comes straight from the QUS, their intrinsic connection isn't really subject to the bending or slowing of time caused by local Q variations or gravity fields in the manifest world. This allows them to remain linked across vast distances without the usual time delays we'd expect.
So the connection isn't traveling through our space-time, it's bypassing it via the QUS.
That's the core idea. From our perspective, looking at the manifest world, the connection appears instantaneous because it's happening via this deeper, timeless layer. Think about those friends on the high-speed train again.
With the secret radio link outside the train's motion.
Right. Even if the train, space-time, twists and turns, Q varies, their conversation, the entanglement connection, is immediate because their link isn't affected by the train's local journey. Entangled particles, in DDTF, have this deep quantum link tied to the QUS, making it resilient to local time fluctuations.
And Q plays a role in breaking this.
Absolutely. Entanglement is notoriously fragile. Any interaction with the environment, which is decoherence, increasing local Q breaks that direct QUS connection. It forces the particles fully into our manifest, time-flowing world, and the entanglement is lost. Lower Q, like in a vacuum, helps preserve it. It really highlights the interplay between the timeless potential and the manifest reality.
Okay, one more fundamental connection. Thermodynamics. Specifically, the second law, entropy, disorder, always increasing. How does DDTF link into that?
This is a really crucial link because it connects time's arrow directly to the emergence process. The second law says entropy, disorder, energy dispersal always increases in a closed system over time. We usually think time passes, therefore disorder increases.
Right, it seems like a consequence of time.
But DDTF flips that script. It argues that the increase in entropy is a direct consequence of continuous quantum decoherence. And furthermore, this very process of increasing entropy through decoherence is what creates time itself.
Whoa, say that again? Disorder creates time.
That's the radical proposal. Here's how it works. When a quantum system decoheres, it goes from many possibilities, superposition, a kind of quantum order, to a single definite outcome. This collapse or selection inherently involves interaction with the environment and leads to a dispersal of quantum information,
which we see as increased classical entropy or disorder.
Exactly. Every single act of decoherence, every quantum decision, inherently increases the entropy of the system plus environment. Now remember, the flow of time F is determined by the rate of these decoherence events, Q.
Okay.
Since Q is the very process driving this entropy increase, it logically follows that time itself is literally born from this ongoing entropic process. The constant transition from quantum potential to classical reality, which always increases entropy, is the engine that creates and propels time.
So it's not just that time allows disorder to increase, it's that the process of disordering itself through decoherence is the generation of time.
That's precisely the DDTF perspective. Time isn't the container for entropy increase. Entropy increase is the mechanism generating the container. It's a profound reversal of the usual cause and effect.
Okay, this theory clearly offers a whole new lens. Let's look at how it interfaces with established physics. How does DDTF's view of time and gravity square with, say, general relativity and time dilation?
It actually aligns surprisingly well, but offers a deeper why. General relativity, as you know, predicts time dilation. Time runs slower in stronger gravitational fields or for faster-moving objects. It's been experimentally verified countless times.
Right, GPS satellites need to account for it.
Exactly. DDTF provides a consistent explanation from its emergent viewpoint. Take gravitational time dilation. Near a massive object, gravity is strong. In DDTF terms, this means decoherence density, Q, is extremely high there due to all the matter and energy interactions.
IQ.
And since time flow F is inversely proportional to Q, F1Q, that extremely high Q directly causes time to slow down significantly near the massive object. It matches GR's prediction perfectly.
But it gives a reason for it at the quantum level, the density of decoherence events.
Precisely. It offers a quantum mechanism underlying the geometric effect described by GR. And while it focuses more on gravity, the theory can conceptually extend to velocity-based time dilation too. Maybe a faster object inherently undergoes more interactions or has a higher effective Q due to its energy,
leading to slower time for that object, as special relativity predicts.
It provides a potential unified explanation. Think of time like a metronome again. GR says it ticks slower near heavy things. DDTF says why? The sheer density of quantum ticks, decoherences, near heavy things physically slows the mechanism down. It complements Einstein, offering a quantum foundation.
So speaking of special relativity, what about objects approaching light speed? Does DDTF offer a way to unify GR and SR through this Q concept?
This is where DDTF really shows its potential for unification. SR and GR are mathematically related, but conceptually distinct. DDTF suggests Q might be the underlying bridge.
How?
Think about SR's predictions as you approach the speed of light, c. Your relativistic mass increases infinitely and time slows down, stopping completely at c relative to an outside observer.
Right, the famous thought experiments.
DDTF proposes an explanation for both phenomena via Q. As an object accelerates towards c, its internal quantum processes undergo what the theory calls extreme condensation. This leads to an incredibly high internal Q value.
Okay, Q skyrockets as speed increases.
That's the idea. If the object could actually reach c, Q would become effectively infinite. And if Q is infinite, what happens to time flow F, given F1Q?
F goes to 0. Time stops for that object.
Exactly matching SR's prediction. But DDTF also connects this to the mass increase. Remember Einstein's E NCXA. Mass and energy are equivalent, and kinetic energy increases massively near c. DDTF suggests this enormous relativistic mass increase is a direct manifestation of that sky-high Q.
So the increased mass is the super dense concentration of decoherence events.
That's the interpretation. It's a denser packing of quantum information processing within the object. So you get this beautiful unification, time dilation stopping at c, infinite mass increase, both explained as emergent effects of the object's internal decoherence density Q, reaching extreme values under relativistic conditions. It weaves SR and potentially GR effects together through this single quantum parameter.
That's really elegant. Let's bring in something more everyday. Heat. How does simple thermal energy fit into this quantum picture? Does it shape space-time too?
Heat, seemingly simple, actually plays a really significant role in the DDTF framework. It's not just about particles jiggling faster, it's directly linked to decoherence and thus to spacetime.
How does that connection work?
Well, fundamentally, heat is increased molecular and atomic motion. More vibration, more energetic collisions. At the quantum level, this means more frequent and more vigorous interactions between particles and their surroundings.
More interactions means more decoherence.
Exactly. Each interaction is an opportunity for a quantum system to decohere, to collapse from superposition. So a hotter system with all that extra energy and motion will naturally have a significantly higher rate of quantum state collapses. That means a higher decoherence density Q.
Okay, hotter things have higher Q. What did that do to spacetime?
According to the core principle F1Q, if Q goes up because of heat, then the flow of time F in that hotter region must slow down relative to cooler regions. It's like an extension of time dilation, not just from gravity or velocity, but from thermal energy density itself contributing to Q.
So a hot star slows time around it, partly just because it's hot, not only because it's massive.
DDTF would suggest so, yes. The thermal energy contributes to the local Q. And there's a further link to gravity. Remember, DDTF sees gravity as reflecting the local density of these entropic events or information nodes, decoherences.
Right.
Since heat directly increases the rate of these decoherence events, it increases the density of these nodes. Therefore, regions with higher heat should, according to DDTF, create a greater local curvature of spacetime.
Meaning heat itself contributes to the gravitational field.
Yes, it links thermal energy directly to gravity via the shared mechanism of Q. It suggests that the energy contributing to spacetime curvature includes thermal energy mediated through its effect on the rate of decoherence. It connects the very small quantum interactions to the very large spacetime geometry through something as familiar as heat.
We keep coming back to entanglement. You mentioned its connection to the QUS. Does DDTF offer even deeper insights? Maybe hinting at really fringe ideas like retrocausality or precognition?
It definitely pushes the boundaries there. As we said, DDTF sees entanglement as particles maintaining a direct, protected link to the quantum undisturbed substrate, bypassing our manifest time flow, T, and local Q fluctuations. They have that time-resilient quality.
Because their connection is via the timeless QUS.
Exactly. Their shared temporal dynamic integrity means their time is closer to the QUS's eternity. Information seems to pass between them instantly because it's not traveling through our emergent, decoherence-driven time. Now, if this connection genuinely bypasses manifest time,
then information could potentially flow backwards or leak from the future.
that's the speculative leap DDTF allows for. If the future exists as potentiality within the QUS, could these time-resilient, entangled connections act as conduits? Could information about a future state, still potential in the QUS, influence a present measurement via entanglement?
That sounds like retrocausality.
It does. Or even precognition, especially if you consider highly complex, coherent systems potentially capable of sustaining intricate entanglement networks, like perhaps consciousness itself.
So consciousness might be able to tap into this QUS potential through entanglement.
It's a highly speculative but logical extension within the DDTF framework. If consciousness interacts with quantum phenomena and entanglement bypasses time, it opens a theoretical door, however small, to phenomena that seem to violate our normal sense of temporal causality. Again, Q plays the role of the gatekeeper. Increase Q, break the entanglement, and you're firmly back in normal forward-flowing time. Low Q preserves the potential for these spookier connections.
Speaking of extreme conditions, black holes. The singularity at the center, infinite density physics breaks down. How does DDTF view that?
Black holes are the ultimate test for any theory of gravity and spacetime. DDTF offers a really different perspective on the singularity. It doesn't just see it as a point where equations fail.
What does it see it as?
It interprets the singularity as a point of ultra-extreme decoherence density, Q, so incredibly high that our concept of manifested time T completely loses meaning. The rate of decoherence effectively becomes infinite there.
Infinite Q means time stops entirely. We established that. But what is that point?
Here's the profound idea. If time emerges from Q and the QUS is the timeless realm before Q creates time, then maybe the singularity is where manifest reality reconnects, where it submerges back into the quantum undisturbed substrate.
So matter and energy falling in don't just vanish.
No. Instead, they and the information they carry return to that state of pure potentiality and coherence that characterizes the QUS. It's like a cosmic recycling center. Entropic manifest information goes back to its coherent potential source.
Which potentially solves the black hole information paradox.
It offers a way. The information isn't lost, it's returned to the fundamental substrate. And this is where the theological dimension comes in strongly. If the singularity is a gateway to the QUS, and divine providence is seen as the architect of the QUS and the flow of time,
then divine providence would have access there.
or influence, yes. It could be a point where divine providence interacts with reality at the most fundamental level, maybe recomposing or redirecting the information returning to the QUS. It suggests information is conserved, but perhaps guided or managed at this deeper theo-cosmological level.
Moving from the smallest points to the largest scales. Dark energy, this mysterious force accelerating the universe's expansion. Any DDTF speculations on that?
Dark energy is a huge puzzle, yeah. This unknown something pushing the universe apart faster and faster. DDTF offers a hypothesis, though it's definitely speculative.
Okay, what's the idea?
It suggests dark energy might not be a separate thing or field at all. Instead, it could be a manifestation of large-scale fluctuations in the overall cosmic decoherence density.
Fluctuations in Q across the whole universe.
Yes, these vast, perhaps very subtle variations in the background level of Q might be what drives the large-scale dynamics of space-time itself, leading to the observed acceleration.
How would that work? Lower Q causes expansion.
Perhaps. Maybe in the vast voids of space where matter density is extremely low, Q is also naturally very low. And perhaps this very low Q state inherently creates a kind of outward pressure on the space-time fabric, causing it to stretch more rapidly.
So it connects the universe's expansion to the fundamental quantum process of decoherence.
That's the speculative link. It tries to explain this major cosmological observation using the core mechanism of the theory itself, suggesting Q operates not just locally, creating gravity and time, but also globally influencing cosmic expansion.
Okay, let's pivot now fully into the philosophical and indeed theological side of DDTF. You mentioned consciousness earlier having an active role. Can you expand on how it shapes reality in this theory?
This is really where DDTF departs dramatically from standard physics. It doesn't treat consciousness as just an emergent property of complex brains that happens to observe reality. It sees consciousness as an active, even essential factor in shaping reality.
How does it actively shape things?
We touched on how conscious observation accelerates decoherence, the measurement problem in quantum mechanics. DDTF takes this seriously. The act of a conscious being observing, thinking about, or intending towards a quantum system helps select a specific reality from the superposition of possibilities.
So our attention influences the outcome.
It participates in the outcome. Think of that quantum coin again, heads and tails at once. DDTF suggests conscious observation doesn't just reveal if it's heads or tails, it actively participates in making it become heads or tails. We're not just audience members, we're part of the play.
And our choices, our intentions.
They also drive decoherence, making a choice, forming an intention. These are complex conscious processes that involve neural activity, information processing, and ultimately quantum events in the brain. These processes generate Q. So DDTF suggests our choices actively weave new threads of information into the fabric of spacetime.
Like the universe is a loom analogy again. Our choices are threads.
Exactly. If space-time is this constantly woven fabric, then every conscious choice, every action driven by intention, adds a unique thread to that tapestry. We are, in a very real sense, according to this theory, co-weavers of the universe.
That completely changes our place in the cosmos. We're not just passive observers.
Not at all. We're active participants in the ongoing creation and evolution of reality. Our existence, our consciousness, is deeply interwoven with the fundamental processes that make up the universe. Every thought, every choice, matters on potentially a cosmic scale.
This idea of purpose leads naturally to the fine-tuning problem. The universe's constants seem exquisitely set for life. How does DDTF interpret that? Is it just luck?
Definitely not luck, according to DDTF. The fine-tuning, the incredible precision of physical constants and initial conditions needed for stars, planets, life to exist is seen as strong evidence against random chance.
So what's the explanation then?
It's interpreted as an expected consequence of the active teleological guidance of divine providence. Teleological meaning purposeful, goal-directed.
Divine providence guiding the quantum possibilities.
Precisely. Remember, DDTF posits that divine providence can tilt the probabilities within the QUS, favoring certain outcomes during decoherence. The fine-tuning is seen as the signature of this guidance.
The God adjusted the knobs.
In a manner of speaking, DDTF suggests divine providence, having the emergence of complex life and consciousness as a purpose, would have meticulously set the initial conditions and fundamental laws within the QUS, so that the universe, unfolding through decoherence Q, would naturally lead to the possibility of life.
Like the director ensuring everything is perfectly set up for the intended movie.
That's a good analogy. The precision isn't an accident. It's a result of foresight and purpose embedded in the very foundation of reality, guiding the quantum dice rolls from the beginning.
You mentioned entropy earlier. Thermodynamic entropy, increasing disorder. Does DDTF talk about other kinds of entropy? A more nuanced view.
Yes, it does. It distinguishes between the familiar chaotic or thermodynamic entropy, energy spreading out, things breaking down, and a second type it calls organizational or qualitative entropy.
Organizational entropy. That sounds counterintuitive.
It does, but think about it this way. Every time decoherence happens, information goes from potential, in QS, to manifest. This increases overall entropy. But if that manifestation results in structure, complexity, or meaning like forming a DNA molecule, a new idea, a star system, then that increase in entropy has a creative organizational aspect.
So some entropy builds things up, in a way.
It signifies the emergence of organized complexity. To capture this, DDTF introduces the idea of the quality of Q, not just its density or rate.
Quality of Q.
Yeah. Organized Q is produced by complex systems, like consciousness, or by processes leading to structure, like atoms forming. This kind of Q weaves space-time towards increased local complexity. Unorganized Q comes from random interactions leading to simple disorder.
And divine providence guides the quality too.
Primarily the quality, the theory suggests. The universe's purpose isn't just for stuff to happen, but for organized information, complexity, and consciousness to emerge. This process, driven by organizational entropy, enriches the time fabric with meaning. So entropy isn't just decay, it's also the engine of creation and complexification, guided towards a purpose.
This concept of quality and Q and inherent purpose, it feels like it opens the door to even higher organizing principles. Could something like love play a role?
That's a profound question, and DDTF, by integrating divine providence and purpose, certainly allows for that possibility. It suggests that love, understood in a cosmic theological sense, could be the ultimate organizing principle influencing the quality of Q and the nature of spacetime.
How would love influence quantum decoherence?
Well, think about the qualities associated with love. Harmony, coherence, connection, unity. If decoherence isn't purely random but guided, Could a principle like love subtly influence how quantum information manifests from the QUS? Could it perhaps enhance entanglement, connection, or favor outcomes that lead to greater harmony or complexity, higher quality Q?
So love as a guiding force favoring constructive outcomes.
Potentially. If divine providence guides Q, and the nature of that providence is love, then love could be the subtle bias shaping reality's unfolding. Imagine the universe as that symphony again. The notes and instruments are fixed, but the conductor, whose essence is love, influences how they blend, creating a more harmonious, purposeful piece.
So love influences the texture or quality of the music being played by the universe.
That's the analogy. It wouldn't change the laws of physics, but it might influence how those laws play out, guiding the quality of Q towards coherence, complexity, and ultimately the universe's intended purpose. It seeks to integrate a core spiritual concept with the proposed physical mechanism.
If divine providence can subtly tilt quantum probabilities like that, does DDTF offer a way to understand miracles without breaking physical laws?
Yes, it provides a framework where miracles aren't violations of nature, but rather extreme examples of this divine guidance of Q.
Extreme tilting of probability.
Exactly. Divine providence doesn't need to override physics, it just needs to influence the quantum probabilities inherent in the QUS so strongly towards a specific, incredibly unlikely outcome that it manifests in our reality.
So it's statistically possible, just astronomically improbable without guidance.
Precisely. The event itself would still operate within the known framework of quantum mechanics and emergent physics. It's just that its probability might be 1 in trillions upon trillions under normal circumstances. A miracle in this view is that astronomically unlikely outcome being made real through focused, powerful, purposeful divine influence on the underlying quantum probabilities.
Like weighting the cosmic dice so heavily they land on 6 foot 100 times.
That's a good way to put it. It's not changing the dice, but profoundly guiding the roll. It allows for divine action within the natural order, albeit producing results far beyond normal expectation.
Bringing it right down to personal experience. Subjective time. How hours fly when you're engaged, minutes crawl when bored. Does DDTF explain that?
It offers a really interesting potential explanation, connecting our inner mental state directly to the local flow of time as we experience it.
Based on consciousness affecting Q.
Exactly. We established that the conscious mind is a hub of complex activity, constantly generating decoherence events and processing information. Now think about brain activity levels.
High activity when focused or emotional, low when bored or resting.
Right. DDTF suggests this high brain activity, intense emotions, learning, deep concentration, translates directly into a local increase in decoherence density, Q, within the brain itself. Conversely, boredom, inactivity, lower mental processing mean lower local Q in the brain.
And higher Q means slower time.
Slower subjective time. So when your brain is buzzing with high Q due to intense processing, time feels condensed, slowed down, packed with experience, even if the clock on the wall seems to tick fast. Think of that slow motion feeling during intense moments.
And when your brain has low Q, because you're bored.
Time feels expanded, like it's dragging. Or, conversely, speeding by unnoticed because fewer internal decoherence markers are being generated to give it subjective density.
So our state of mind literally influences our perception of time's passage by altering local Q in our brain.
That's the fascinating implication. It offers a potential physical basis for subjective time, rooted in the theory's core principles. It reinforces that consciousness isn't just watching time flow, it's actively shaping its local experience of it.
Okay, let's try to synthesize all this.
Yeah.
DDTF seems to be building a bridge between science, philosophy, theology. How does it reconcile big concepts like free will and divine providence?
It tackles this classic paradox through what it calls divinely guided probabilism. It's not pure determinism nor pure randomness.
A middle ground.
Sort of. The foundational laws, the possibilities within the QUS, these are seen as divinely established, perhaps deterministic at that level. But the actual manifestation of events, the specific outcomes of decoherence that create our reality and time, those are probabilistic.
And that's where free will comes in.
Exactly. The probabilistic nature allows for genuine openness, for choices to matter. Divine providence then acts by guiding these probabilities, nudging the universe towards its intended purpose, but without overriding every quantum event or negating our freedom.
Like the board game analogy. God designed the game and rules, gently nudges the dice, but we still choose our moves.
Precisely. It allows for both a purposeful universe guided by a higher power and genuine freedom and responsibility for conscious beings within that universe.
And this approach allows DDTF to aim for a truly holistic framework, unifying these different disciplines.
That's clearly the ambition. Scientifically, it tries to connect quantum mechanics, decoherence, with relativity, emergent spacetime gravity, and thermodynamics, entropy. Philosophically, it addresses deep questions about time, reality, purpose, consciousness. And theologically, it explicitly incorporates purposeful creation and ongoing divine action.
Like fitting the jigsaw pieces of science, philosophy, and theology together.
Yeah, attempting to show how they form one coherent, grand picture of the universe, rather than being separate or conflicting views. It's a quest for a unified understanding of existence.
And central to that unified picture is this idea of a teleological universe, a purposeful one.
Absolutely. DDTF strongly argues against a purely random, accidental cosmos. It posits a universe with an inherent goal and intended direction.
And that direction is set and guided by divine providence.
Yes. Divine providence is seen as the initiator and continuous guide of the decoherence process, Q, originating from the QUS. This guidance shapes spacetime, directs the flow of events, and ensures the universe evolves towards its ultimate purpose.
Like the author guiding the story of the universe towards a meaningful conclusion.
Exactly. It suggests that every quantum event, every moment of time's unfolding, is subtly influenced by this overarching divine plan and purpose.
Let's explore a few more of the theory's extended insights. You mentioned the universe as potentially like a living organism, metaphorically.
Right. If time is woven from decoherences and consciousness produces organized Q, you can start to imagine the universe less like a machine and more like a vast evolving entity. And within that picture, divine providence could be seen as the overarching cosmic consciousness guiding the whole system's development.
And does this evolving universe feed back into its source, the QUS?
DDTF suggests it might. As the universe creates complexity and qualitative entropy organized information, this newly structured information could potentially enrich or add to the QUS itself. Creation wouldn't just draw from the source, it might also contribute back to it, adding unique configurations of information.
That's a mind-bending idea. And where does humanity fit into this cosmic consciousness picture?
If God is viewed as cosmic consciousness, and humans uniquely possess organized Q generation and free will, DDTF speculates we might function akin to neurons in this cosmic brain.
Our choices and thoughts contribute to the cosmic mind.
Our conscious activities, creativity, learning, seeking truth actively contribute to the qualitative evolution of the cosmic Q. We help weave the time fabric in line with the divine purpose. It makes us integral parts of a thinking, evolving universe.
This leads to ideas about the end times, eschatology. How does DDTF frame concepts like a second coming or a final state?
It interprets these not just as historical events, but potentially as the cosmic completion of this whole DDTF cycle. It could signify a point of maximal increase in organized Q, the full flowering of the divine plan in manifest reality.
Or a return to the source.
Or perhaps a collective return of the universe's information to the QUS, but now as a completed time fabric, fully realized and imbued with all the meaning and complexity it generated. The idea of a new heaven and new earth could represent this final, perfected configuration of spacetime in total harmony with the divine will.
And our free will plays a role in that final state.
Critically, our choices, generating organized Q, contribute to the ultimate quality and structure of that final cosmic state. Free will becomes an eschatological responsibility, a duty to help fulfill the divine plan and contribute positively to the universe's final perfection.
You mentioned compatibility with Orthodox Christian beliefs specifically. Can you quickly recap those connections?
Sure. Creation ex nihilo, out of nothing, finds resonance with the QUS being the state before manifestation, with God activating Q to bring forth time and reality. Divine providence aligns with the guidance of quantum probabilities. Creation of humans in God's image connects to our ability to generate organized Q and shape local time, mirroring the divine capacity. And continuous creation, creatio continua, maps onto the ongoing process of time emerging through decoherence, a constant unfolding of reality, potentially guided by the Holy Spirit.
And physically, space-time is seen as this network.
An information entropy network, yes, woven from entropic events, decoherences, each acting as an information node where potential becomes manifest. Entropy isn't just disorder, it's the creative force transforming potential into actuality, and gravity is simply the density of these information nodes in the network.
So, wrapping up, What's the ultimate value of DDTF? It's not easily testable right now.
True, its empirical validation is a challenge, like many unified theories initially, but its immense value lies in its power as a philosophical and theocosmological framework. It provides a coherent, unified way to think about reality, time, and purpose across disciplines.
Challenging purely materialistic views.
Exactly. It suggests the universe imbued with meaning, part of a grand design rather than just random events. It offers a radically different perspective, forcing us to question basic assumptions about time and reality. That alone is incredibly valuable for stimulating new thought.
It suggests the universe isn't just laws and randomness, but maybe a living narrative.
That's a beautiful way to put it. A narrative with time as its emergent canvas, woven by quantum interactions, guided by providence, and perhaps even co-authored by conscious participation.
Which leaves us with a final thought. If the DDTF theory holds even a hint of truth, if every moment, every choice we make contributes a unique thread to this immense cosmic fabric, what kind of universe are you helping to weave?